Welcome to homework.
So the goal of this question is to explain if there's a difference in the acceleration due to gravity when you're at the top of Mount Everest than at sea level. Now, whenever you're dealing with the acceleration due to gravity, what should immediately come to mind is Newton's second law of motion, which is F is equal to mass times acceleration. And this is your acceleration due to gravity. So here we're dealing with two objects, you, the person standing at sea level and at the top of Mount Everest, and the Earth, the thing you're standing on. Also notice that the distance is different when you're at sea level than at the top of Mount Everest. This means we can use a second equation called Newton's law of gravitation, which is F is equal to capital G, the gravity constant, m1, m2 divided by d squared. This is m1 is your mass, m2 mass of the Earth, and d squared is the distance between you and the center of the Earth. Now looking at these two equations, you'll see that they have the same F, which means we can set them equal to each other. So let's do that. On the left side, you have this equation, ma, and this is m1, your mass, is equal to this equation, capital G, gravity constant, m1, your mass, m2, mass of the Earth, divided by d squared. Now the left and right side have m1, so that cancels, and you're left with, on the left side, acceleration due to gravity. On the right side, gravity constant, mass of the Earth, m2, divided by d squared. So now let's examine this equation. On the right side, what variable is affecting the acceleration due to gravity? Well, capital G, the gravity constant, that value doesn't change. m2, the mass of the Earth, that value doesn't change either. What about d squared? Remember, this is the distance between you and the center of the Earth. So yes, this does change, which means that changing your distance affects acceleration due to gravity. And because d squared is in the denominator, this relationship is called the inverse square law. And this tells us that acceleration due to gravity is inversely proportional to d squared, which means that increasing your distance or getting farther away from the center of the Earth decreases acceleration due to gravity. And the reverse is true. As you decrease your distance or get closer to the center of the Earth, the acceleration due to gravity increases. And finally, with all that in mind, our answer should be clear now. Because you are farther away from the center of the Earth at the top of Mount Everest than at sea level, the acceleration due to gravity at the top of Mount Everest, which we'll call AM, is less than the acceleration due to gravity at sea level, which we'll call AS.